My name is Ryan Waldron. I work for the Division of Water. One of my responsibilities for the division is to be the CSO Combined Sewer Overflow Program Coordinator. Based on the amount of interest that we've gotten in this project and the number of people that have shown up, either you guys are really interested in what's going outside or you're just mad that your parking's been interrupted for the last couple months. But I do promise you that the project is very beneficial to the City of Albany's infrastructure as well as the water quality of the Hudson River. And then we also have Mike Miller, who works for CHA and who's the person who was responsible for designing the project. He also serves as like a technical advisor to the Albany pool communities, which he'll go over what that means.
So what we wanted to do today, Ryan did ask me to kind of take a step back and just give a little introductory course on CSOs so that we can frame this whole discussion and some of the goals and objectives that the Albany Water Board is tackling. We're going to give a little bit of a background on the Albany Pool CSO Long-Term Control Plan and what that means. We're going to highlight some of the projects that we've been working on the past couple years just to give you a flavor of what else we're doing beyond the Floatable Control Project. And then, of course, the featured project is the Floatable Control Project. That is what we were asked to kind of come in. That's what everybody's wondering about, what this big hole is outside the DEC building. So we're going to go through that and hopefully shed some light on that. And then we'll open it up for some questions. And some of you may be brave enough to go out in the weather and take a view from top deck. So hopefully I'm not surprising too many people in the room this morning when I say the City of Albany, like many older communities in the Northeast, operate their systems utilizing combined sewer systems. And what that means is we share a common sewer in sections of the city to convey both wastewater and stormwater. So under these conditions, this is really prevalent in the Northeast. Most of your urban cores across the state have CSO systems. But during dry weather conditions, the wastewater is collected in the system and it's intercepted down along the river and conveyed to the South Treatment Plant that is owned and operated by the Albany County Water Purification District. During wet weather, the systems are actually designed so that if you exceed the capacity of the pipes, the treatment plant, it kicks to the river. So we discharge during wet weather periods and convey combined sewer flows at overflows to the river. So in terms of the Albany Pool, some of you may have heard the Albany Pool Long-Term Control Plan. What it is it's referencing 6 communities along the river in the Capital District: City of Albany, City of Troy, Waterville, Cohoes, Green Island, and Rensselaer. The 6 communities came together to develop a common plan in conjunction with the Rensselaer County Sewer District and the Albany County Water Purification District. They said it couldn't be done, but the team stayed together and we are actually implementing the program under a local development corp. So just to give you an idea, the 6 Capital District communities discharge about 1.2 billion gallons of CSOs to the river on an annual basis. Those are baseline conditions from when we did the initial study. So some of our work as we're moving through the program is obviously reducing this. The number one goal of the consent order is to reduce untreated combined sewer flows to the river. Within the City of Albany contributes about 750 million gallons on an annual basis. The vast majority of that comes out one single discharge point, affectionately known as Big C. It's the discharge point associated with the Beaver Creek Sewer District, and we discharge approximately 520 million gallons on an annual basis from that single discharge point. So our mission statement. Our goal as working together with the 6 communities was to develop a cost-effective regional solution to achieve water quality standards, maximizing the environmental benefits in consideration of public health and welfare, and of course the financial impacts to the member communities. Long and the short, we were tasked with developing the most cost-effective plan to ensure that we're meeting water quality standards. So in terms of the program, really at its core, it's a clean water initiative. It's to clean up the Mohawk and Hudson River and improve the water quality in the receiving waters. Again, the goal was to produce a comprehensive solution that really focused on the reduction of untreated wastewater or combined charges. The plan was approved in January 2014. It's nice to see Joe back in the building because he was a big part of helping us through that process and getting to the point where we had an approvable plan. And we're in year 5 of a 15-year implementation period. So when we developed the long-term control plan, we really utilized a broad-based approach in terms of various mitigation strategies. We're disinfecting wet weather flows at the plant and also a satellite treatment facility associated with Beaver Creek. We looked at process improvements at the plant, system optimization work, sewer separation and storage, green infrastructure projects became a big part of the negotiation discussions, screening at critical outfalls, and that's really what we're talking about when we talk about the Floatables project, as well as some tributary enhancements and some additional pool-wide projects. So this is a project that we undertook this year. We undertook it a little early relative to the consent order because we had some emergency conditions. Bauk Street Regulator Optimization Project, it's one of 2 really major optimization efforts that are going to take place in this calendar year. You can see these are the challenges that we face. We were literally installing a new manhole over the county interceptor, tying it back to an existing control structure, and installing about 10 feet of pipe. Within the city environment, though, we had to deal with the electrical ducts, the telecommunication ducts. You can kind of see them up here as we're supporting them. You can see the rather extensive shoring systems that were required. We're about 15 feet below grade here on South Pearl Street. This little 10-foot project is probably going to ring in over $500,000. But these are the challenges that are faced when you're dealing with fixing problems in these urban areas. So we wanted to share with you some of the other projects that we've been doing, and we've worked with Ryan a lot on these projects. We've worked with our friends at EFC a lot on these projects that involve sewer separation and storage and green infrastructure components, just to give you a flavor of some of the other things that we're doing in the city. So anybody familiar with the Woodlawn Park area would have seen the new wetlands, the constructed wetlands that are putting up there. The new wetlands created about 350,000 gallons of storage. And essentially the strategy that we're doing with some of these offline storage units is we're separating stormwater flows and bringing them to constructed wetlands and some other elements that we'll review. And then we're optimizing the performance of those elements using the OPTI controls, or really continuous monitoring and adaptive controls. And again, it's actually a very exciting process. The city's done a lot in terms of placing meters in the system and really starting to get a better understanding of how the systems operate, both during dry weather, wet weather. It really does serve as a warning when things are happening in the system. This is all buried infrastructure. So for the last 200 years that it's been out there, we hope that it's working fine, and we hope that we don't get those phone calls when the roadway collapses. But this has given us real data, real-time data on a daily basis, letting us know how the system is performing. And we're using that data to identify problem areas within the system where we may have some maintenance concerns that need to be addressed, and really starting to understand, where the challenges are within the system. So this is actually one of the low-level adaptive controls that control the flows out of the wetland. And those are all construction photos. You can see it going in. Actually resulted in a very nice project for the neighborhood. One of the other projects we did up in the Woodlawn area involved putting in an underground cistern system below the ball field out there. So we have huge storage cells beneath the ball field, providing 750,000 gallons of storage. Again, the outlets are controlled using the OPTI control system. And we actually got a ISC grant to go in and modify, and we're going to use the stormwater that's collected for irrigation of the field, as well as possibly some of the street cleaning operations within the city, and also possibly make that water available for maintaining and watering other green infrastructure installations in the city. So here you can see some of the cells going in. That really was the best the field ever looked. It was a beautiful field, and still is. But they got all new sod, so the Babe Ruth League was thrilled with the project. So one of the other projects that we completed last year dealt with Washington Park Lake, and it also, again, was creating storage with flow controls for during wet weather periods. The first phase of that project was a green infrastructure project along Quail Street. It's about a 1,700 linear foot corridor, 8 city blocks, both sides of the street. We installed green infrastructure, plantings, porous sidewalk treatment areas, and put in storage cells beneath all the sidewalks. That system had passive controls to really help check that water and keep it back and promote maximum infiltration within the cells. And then we later connected it with a new storm sewer installation along Elberon Place to connect that system to Washington Park Lake. Now, we love this project. Washington Park Lake presented an opportunity where we were able to grab up to 7 million gallons of storage in one shot without having to create anything. All we have to do is manage the lake levels. So the nice thing about the Opti system is it is incorporating weather predictions along with actual sensors in the field letting us know what the current lake levels are. And based on that data and that sense of and those algorithms, it'll tell us how much to drain the lake down before the event and whether we're going to have the storage available in the lake to hold it back for the entire event or not. So just a quick overview of the logic. Essentially what we're looking at is we're looking at what the predicted volumes of the events are, and then we made a decision to draw down about 50% of that. So if it tells us it wants 1 million gallons, we're gonna draw down about 500,000 before the event. The reason being we always want the lake to skim somewhat so that we get flow moving through the lake so that we don't get an accumulation of algae or other materials on the lake surface. So essentially we're looking at the volumes that are predicted for the event, and then we're asking ourselves the fundamental question: do we have the available storage to hold this event back? If we do, we don't discharge at all during wet weather periods. To date on this system, we're capturing over 95% of all wet weather flows. And after the event passes, we do an extended drawdown based on flow conditions in the system. So between this system, the 2 systems up in Woodlawn, some other installations that are going online this year, I think we're up probably between 8 and 9 million in storage volume to date, probably be over 10 million by the end of 2020, we'll say, with probably 10 of these installations scattered through the city. So I only like this because I like the drone footage. But these projects, Beaver Creek CSO Abatement and Flood Mitigation Program, it was acknowledged this year and recognized through ACEC New York, received a Platinum Level Excellence Award. And it really just goes to show what the city's doing. This is really cutting edge stuff. From a wastewater system perspective, we're building operational intelligence within the system. You know, we hear it a lot about traffic signals and highway systems, and we're all building smarter infrastructure. We're building smarter infrastructure within the wastewater system. And as Joe mentioned before, this project was in fact featured in a CNBC video series on risk management and climate change. So it's cutting edge stuff, and they deserve a lot of credit for moving forward. So now we're getting closer. We're talking about screening at critical outfalls. I did want to provide a quick update on the Beaver Creek Clean River project for those who may know about the project. This is really the marquee project within the long-term control plan. It involves satellite screening and disinfection for the Beaver Creek outfall. Again, that's the largest discharging outfall in the city and throughout the Capital District at over 520 million gallons a year. We've cited it. We are happy to say we've completed a very extensive public outreach and education program that has probably expanded well over the past year. But we got a lot of great input from the community, and we were actually able to adapt the design and address their concerns, and received a lot of positive feedback from the community as a result of that. So the system is proposed to be up in Lincoln Park under the new concept. We're actually going to build a little resiliency into the system and create a cross connection over to 3rd Avenue. What that allows us to do is it's going to allow us to keep all the solids within the system itself, have a direct connection to the Albany County Sewer District, and basically handle the solids. All that solid storage and management will happen at the treatment plant, which the community felt was a much better place for that to happen than Lincoln Park. And we agree. It's one of those things where the public outreach period really drove the final decision. It forced us to take a step back, approach the county, and really look at the project differently and create a partnership with Albany County on the project. It's a win-win. They're going to get new screens at the plant. Instead of us putting big expensive screens out in Lincoln Park to remove materials, we're going to replace the screens at the treatment plant so that they're more suitable for this type of application. And they get the added benefit. It's actually going to improve the operations at the plant. It's a much smaller screen. Right now I think they're 1-inch screens. We're going to take it down to about 1/2 inch. So we're going to be removing a lot more solids, and they're going to have a much better running plant as a result of it. So the Beaver Creek Clean River Project, it addresses the highest priority as defined by the DEC. We're going to provide cleaning of 300 million gallons of annual combined sewer overflows on an annual basis. In DEC lingo, it helps bring the total wet weather capture up to 85% for the city as well as the Capital District. So that was kind of a key threshold that we wanted to meet. And by far, it provided the greatest cost effectiveness in regards to generating water quality benefits for the Hudson River. It's very unusual that you have that large of a discharge pipe that drives so much of the overflow volume. So where a lot of communities may have to tie a lot of outfalls together to achieve this type of result, we were able to avoid that. So here's the reason we're really all here today. We want to go over the floatable control project. The City of Albany Floatables project is the installation of 5 screening facilities within the city. There's actually 2 smaller systems that we'll talk about, and then the 3 larger systems that are similar to Orange Street. So Orange Street is a larger installation, and we'll go over both of them. So real quick, the 2 smaller sites are down on Maiden Lane and Steuben Street. All the sites are downtown. All the sites are, within striking distance of historically sensitive areas. So there's quite a bit of archaeological work that took place as we went to construction. We were able to clear 4 of the 5 sites. The 5th site, we ended up doing an extensive phase 3 investigation, and they'll be documenting the results of their findings over the next year. So I noticed this one came out a little light, so we'll do our best. But with the smaller systems, essentially what happens is you're putting a new structure with the screens directly in line with the overflows. So if you can imagine an overflow pipe, you're literally digging it up, taking a piece of pipe out and dropping in this screening device. And then the solids that are collected return back to the county interceptor pipe. So essentially the way the smaller units work is there's a cylinder in there. In our case, we used 2 cylinders at each one of the sites to get the design flows that we needed. But there's a main shaft assembly, which is a weighted system, so as water starts to enter that system, it'll start to spin on its own. And what that does is, as you can imagine, it's forcing water around the inside of the screen to help kind of create self-cleaning properties. The other thing is the materials that they use on the screens themselves is it's pretty slick, so it's a really smooth surface, so it tends to be self-cleaning as well. So the three larger sites are Orange Street, Quackenbush, and Jackson Livingston. So they're all north of the DEC building. Of course, the one that you got the best view of is Orange Street. That's the one that we're finishing up part of the construction on this year. You will note we didn't start at Orange Street. That's because we deliberately wanted to make sure we worked through all the wrinkles before we put it on display in front of 1,200 interested parties. So that was no mistake. So there's a lot going on here, and what we're going to do is we'll kind of step through it and break it down a little bit more for you. Right now, for those who are looking out the building, 4 of these structures are in place. There's the splitter box, which we'll talk about, the 2 SANSEP units, which are the screening devices, and then they're returning to pump station. So we're using SANSEP units out in the field. They're screening devices. They're made by PW Tech. Incidentally, it's the same company that developed the CDS technology. They just happen to sell the CDS technology. They sold the rights to that as a stormwater application to another party, and then they kept the CSO applications, and now they're branded PW Tech. So those of you who may have been involved with the project in Cohoes where they used a CDS unit, this is similar technology. You can see on the section, the inlet actually comes in low and then discharges high. So as water is entering the unit, it's spinning. You're taking advantage of Stokes' law and the settling properties. Operates very similar to a lot of stormwater treatment devices that utilize a vortex design. So it's similar in that nature. These do not have the screens. What you're seeing in this photo, again, here's your low-level inlet and then your high-level discharge point. So flows are coming in at the bottom. They're swirling around the screen, moving through the screen. Obviously, the solids are settling, and any floatables devices are contained within the screen itself. So within these pictures, you're starting to see the installation of the screens themselves. The white part that you see in this photo is actually the screens. The stainless steel part is actually part of the upper support system. The screens are 10, 12 feet deep, and these utilize I think 10.5 foot precast manhole. So these are fairly large units. These are the largest units that PW Tech manufactures. We utilize twin installations on each one of the sites. So let's start walking through this, give you a better handle of it. So under normal dry weather conditions, flows are coming down Fox Creek, coming down Orange Street. This is your parking garage. This is the beautiful DEC building. So we hit our control structure, and under normal dry weather conditions, flows then get conveyed directly to the Albany County Hudson River Interceptor pipe and get taken to the south plant. So that's what happens during normal dry weather. Flows are coming down and they're bending. They kind of go through your causeway there, the area between the parking garage and the DEC building. As we start to experience the wet weather flows, essentially what's going to happen is that smaller connection pipe to the county interceptor is going to, the capacity is going to get exceeded. So before the project, the flows simply spilled and went to the river. So we've installed a new diversion structure here, and then during the first lower storms, water will be diverted over. This is the splitter box. This is the splitter box here. You can see that from the top of the garage. These are the 2 screening units. You can see those from the top of the garage right now. And then you can also see the pump station down here, and we'll talk about that in a little bit. So what's happening is flows are coming into the first unit. They're swirling around the chamber. They're being released high, and you now have treated combined sewer discharges that then get conveyed to the overflow. So there is a pump station here, and essentially the function of the pump station is not to pump the flows coming in. It's essentially a washing system that's occurring during the operation of the system itself. So the manufacturers look for anywhere from 2 to 10% of the flows coming into these systems are kind of moved through the pumps and conveyed back, and what that does is it's removing solids during the wet weather operation as well as some of the floatables. So the pumps turn on periodically, they drain the units down, kind of clean it out, and then the operation starts all over again. We did include a vault structure here. When we were working with Albany County, they wanted to make sure that if the sewers were surcharged, if their interceptors were surcharged, that we had a means to take care of the system. So essentially we have meters within their system that are going to tell us whether they're surcharged or not, and depending on what their flow conditions are within their system, it dictates whether we can turn those pumps on or off. In other words, if their systems are already surcharged, they don't want additional flows being forced into the system, which could cause surface discharges. And we absolutely agree with that. So we did include extra deep sumps within the facilities. In case we did have periods where we couldn't be discharging, we have more storage within the systems. And within the vaults, we actually have quick connects, so that if we want to come out after the event and pump directly to a back truck, we can do that as well. So it gives us maximum flexibility in terms of how we want to maintain the system moving forward. So as you get higher flows, obviously, you're going to exceed the capacity of the first sand sep, and then it's going to activate the second one. And again, they're using a common pumping station, and you're going to discharge treated overflow. So the 3 larger sand sep units, the 3 installations on Orange, Quackenbush, and Jackson Livingston can treat up to about 62 million gallons a day. Those are peak conditions. What we normally see, though, for most overflow events, they're very flashy. So you get a little rain, you'll overflow, sometimes 15 minutes, sometimes it's a couple hours. It can be longer, but most overflows generally occur 2 hours or less. And then in total, the units are actually treating about 125 million gallons on an annual basis. Again, even though they have that peak capacity of up to 70 million gallons, you very seldom see that. As a matter of fact, they're sized for the 90th percentile event, kind of similar in principle to how we do water quality calcs for stormwater. And then during extreme conditions, if you exceed the capacity of the screens, we can have discharges to the river, untreated discharges. Okay, so we'll walk through some of the construction photos for those who may not want to brave the weather today. These are early pictures before we started digging too deep. You can see the vertical rails there. They go in, they get driven in, and then we're using a slide rail system where we're sliding in steel sheets in between them. It's actually first time I've used this system, and it's actually a pretty slick system, and it's worked very well. At least that's what Ronnie tells me. We'll see if they use it again next year, but I suspect we will. So here you can see we're just starting to dig down. Here we're getting pretty close to the bottom. We're down about 35 feet. So these are deep installations. These larger units are all pretty deep. If you do the math, we're about 10, 12 feet below the elevation of the Hudson River. So as you can imagine, we're dealing with dewatering operations out there. They've got a well point system installed around the excavation that they've been maintaining. I think the well point systems worked extremely well. I think the biggest challenge was dealing with all the rain we had this fall. Again, here you can see we're just starting to set the sub-base materials to set one of the structures. Now we're starting to come up. Again, for those who do go out and look on the garage today, you'll actually see 4 structures out there. You can actually see the splitter box. You can see the 2 screens. Two screens should be easy to pick out. They're the ones with the rail system inside and the inside cylinders. And then the underflow pumping is out there as well. There is an additional structure that's going to go in. It goes in at a higher elevation, so it's not quite set yet. So that's off on the side right now. This is actually a picture of Quackenbush as they started to connect the high-level treated discharge pipes. So this is Quackenbush. You won't see that on Orange today. This structure is sitting off on the side outside the excavation limits right now. Again, that's Quackenbush. I only like this picture because I caught Ronnie with on his hard hat. So the benefits of the project. The reason that we selected these outfalls for screening was because they all discharge along the banks of the Corning Preserve. So as you know, the Corning Preserve is the premier waterfront location within the city of Albany. A lot of recreational activities and events held down there. So we wanted to do the best job we could in terms of addressing the discharges at those outfalls. We're providing cleaning of 125 million gallons on an annual basis, and we're actually capable of providing peak treatment levels up to 70 MGD. So a little bit on the project timeline. The two smaller sites are done and operational. We finished those up this fall. So Orange, or Maiden and Steuben are completed. Quackenbush we should be doing the startup and commissioning in January, is what we're looking at. So that'll be the first one of the large sites that goes online. Orange Street, which I know you're most concerned about, we're going to be finishing up essentially the structure installations this fall, and then we're going to button up the site for the winter and come back and make the connections in the roadway in the spring. So you're going to see a shutdown period. We're going to go in, do temporary surface restoration within the parking lot, get that operational again for CDTA, and then we'll be back probably in April, and we've got to make some cross connections actually going across to Orange Street. Jackson Livingston, that's the one where we were talked about and we had to do the phase 3 archaeological dig. We're cleared. We finished the archaeological work at this point. So the contractor should be going in there as well early April and probably finishing up early fall. So given who's in attendance today, special shout out and thanks to all our project partners and sponsors. We couldn't do these projects without the partnership of the DEC and the EFC. Many of you in this room may know about the projects. Maybe some of you don't, but I can assure you the state, both DEC and EFC have been wonderful partners to us on this, not only in terms of working with us on the long-term control plan development, but in terms of the development of these projects, getting them approved, getting them permitted, and it's a great time to be a wastewater engineer because there's lots of money flowing from the state, so thank you. We really do appreciate that.